let's see if that works. Yes. All right. So I want to tell you today a little bit about the computers that we have and how we maintain them, organize them, and all of that. And so as usual, it's all going to be just a demo because I don't particularly like PowerPoint. So, oops, did I just disconnect it? That's going to be back. All right, so I've got a talk already here. And there's my abstract that you've already seen. This is merely for my own notes, but I will be showing you in this window some demo. But there is a little bit of an overview of our machines. We organize them into various regions, and over time we've changed the way we've organized it. But more or less, we've got stable machines and research machines, and printers and other stuff. But stable machines are ones that we do our best to make sure they're working. And we do good backups on them, and we keep the software up to date. And the research machines, less so, although we also try to keep them running. And within each of those, we have subgroups, like the machine sitting on my desk is a stable faculty machine. And the multi-lab machines are stable student machines. Actually, multi-lab has its own group as well. In research, we've got a group called Production AI Lab, which is mostly on the third floor of this building. Jacobs, which is Nathan Jacobs' machines, and so on. And this changes over time, how we organize that. And so what I want to tell you first about is, oh yeah, I'll mention this, that we used to use physical machines for everything, and we don't anymore. We did use different physical machines for different purposes, so that if there was a problem with one of them, the other purposes would still be okay. One of the machines was the mail server. A different machine is the web server. So if our web server goes down, mail at least gets through. And if the mail server goes down, well, the web at least is still working. We didn't want to put all of our services on one machine. These days, we've kept that, but these machines, most of them, about 8 of our machines now, are virtual machines. They're being hosted using QEMU hosting, virtualization, on 2 machines. And if one of them goes down, that takes down about 4 machines. But then we can quickly slide their last known versions across to the other machine. So even if we have a major outage, a machine actually breaks, and we can't fix it immediately, we can bring up all of the virtual machines that were running on its partner machine. So we haven't had cause to need that yet, but looking ahead, who knows? Machines do fail. And most of our Linux machines were recently upgraded to the most recent Ubuntu. The way Ubuntu numbers works, Ubuntu is a distribution of Linux. Linux is a version of Unix. And Ubuntu numbers its distributions by the last 2 digits of the year. 2016, for example, is 1.6. And then every year there are 2 distributions that come out, April and October. 04 is April, 10 is October. So it looks like we're almost a year behind, but we're not, because the 04, every even year, is a long-term release. And so this is something that they will keep supporting for 6 years. And the previous long-term release was 1404. And so some of our machines are still sitting at 1404, but most of our machines have been upgraded recently to the 1604. Okay, so I've got various categories of things I want to tell you about. I want to tell you about setting up new machines and keeping machines aware of changing environment. And the way I'm going to show you that is by going to a place called Puppet. That's just a machine. And we call it Puppet because it is the puppet master. How many of you have read the science fiction series, Ivan Niven, about the puppet masters? No one. Well, that's why it's called this, because there's an alien race in the science fiction where there's a group of aliens called puppet masters. Anyway, on this machine, I will show you this, which is one of its configuration files. All right. Puppet is a service. It's a facility whereby if you've got files that you want to distribute to a bunch of machines, you can store them on the Puppet Master, and the Puppet Master can then download them to those various machines. We use it primarily when we first get a new machine up, because there's certain files we want to have. It just shows that it's one of our machines. right? So we use Puppet Master for that. We also use it periodically. It can update any file that you want. So here is its configuration list. And it says that a base node has all of this stuff, and some other machines have other stuff. If, for example, I noticed that Samba is included for the machine Amos. We have one machine called Amos. It's a .csr, so it's most likely a research machine. And it inherits everything that the base node can do, but it also has a few other things. It has, for example, CS Samba. Now, how many of you can guess what Samba is? All right, 2 of you. Samba comes from SMB, which is a much worse acronym. SMB is the Microsoft facility for sharing files across machines. Now, these aren't Microsoft machines. On the other hand, a Samba server is able to export its files to Microsoft importers, Microsoft clients, so that they can think that they're actually talking to a Microsoft file share. So it turns out that Amos is a Samba server, and so it needs the Samba stuff. Well, where is that Samba stuff? That is in at set of Puppet modules. Well, here it is. This is the file which has to be put on Amos because of Samba. It's a configuration file, I assume. I can't read this. I mean, it looks like it tells Samba something or other in whatever format Samba wants, I assume. Or it might be Puppet specific. Paul, is this Puppet specific or Samba specific?
That is 100% Samba specific. That creates a share called drop off.
Okay, this is Samba specific initialization stuff using, it makes a share called drop off. Good. So anyway, we do that for lots and lots of files that we want to make sure are available on particular machines and have certain content. We've started using this maybe 3 or 4 years ago. We have an older thing that we still use, which I'll show you next. Files that are machine-specific or change frequently. When we bring a new machine up with a new name, someone buys a machine and it puts it in the lab and wants to run it, all of our machines need to know about it so that they can connect to it. It's got an IP address. How do they find that out? Also, from outside, if you want people to be able to access it from outside, then it has to have a DNS entry, domain name service entry. How does that all get set up? Well, it does. It's done by an automated technique that was built by a master's student here many, many years ago, about 30 years ago, well, 25 years ago. Brian Sturgill built this as a master's project, and we've used it ever since. After he finished his master's degree, he ended up marrying Dr. Marek's daughter, and he comes to town every so often, and I really enjoy my discussions with him because he always has something new to show me. Anyway, so I'm going to show you that. And I'm going to do this not on Puppet, but on another machine called Al. All right, so I've just gone to Al. And I want to show you one of the things that we organized through SAT, which stands for the System Administration Tool. So this is a database. It's run off a bunch of data. And the data can be brought into a text editor, which is what I just did. And if you open it with permissions in the right way, you can actually change the data in the text editor. When you leave the text editor, those data are changed, and whatever change that requires is propagated to all of our machines. And so this particular database is the hosts database, which is a database of all of the machines that we have. Look at the top one. We've got various fields. I'm sorry, this isn't the host database, this is the mounts database. I have to tell you what mounts are. When we want to share a file, or actually share a whole directory from one machine to another, the wording that's used in Unix is that the client mounts that file system from the server. Right? So mounting is something a client does to access a file system that is provided by some server.
Many of our machines have extra disks, and they act as servers to other machines. And so what this says is that there is a server called Al, and it's filed, its directory ULD3, which is a convention that we use to say the third disk on Al, is being exported. To whom? To all of these machines. All computer science machines, except those that are not applicable, those that are known to be down, those that are printers, which have no interest in mounting anything, all those that are running Windows, because they don't know how to do it, and the Viz Center doesn't mount from Al. The Viz Center only recently became integrated into our machines within the last year, and it's really a separate environment. They don't mount stuff from Al. So this is a set theoretic description of which machines, referring to macros that are defined elsewhere. And the way they should mount it is they should put it on their machine as U/LD3. And it's exported with these various things. It's exported read, write, and other stuff. It is a network file server, network file service type of export. And it's got other fields that aren't so important. So that's what Al exports. Let's see what Bud exports. Bud exports several things. One of them is Bud D2. Not surprising, it goes to a place called UBud D2 on a whole bunch of machines. How about Bud D5? That one's not exported. There is a Bud D5. The only way you can get there is by being on Bud. Yeah?
Why are there so many abbreviations?
As like Bud,
Yeah.
short for Buddy. We have the convention that all of our machines, no matter what their name is, can be identified by the first three characters. And we make sure that they're all different in the first three characters. And so my machine is Gloucester, but GLO is enough to identify it. And we'll see as I show you further why that is. Now, these are not abbreviations. These are macros.
Okay.
Okay? And why use a great big long name for a macro when a short one will do if it's intelligible? All right, so whenever that changes, and I can change it right now, I do have the necessary permissions, then all the machines, within a certain amount of time, it takes a while for this to propagate, on the order of minutes, all those machines will get a new copy of the data. And they will run a program against that called the report program, which will build on that machine whatever files are necessary to understand that stuff. Now, it used to be that we had different versions of Unix. They would use different formats for how they knew how to import and export. And our program understands how to do that. At the moment, that's not the case, but I will show you what the program looks like. Here is the program. It's written in Perl, and this is all comment here, but this tells you in the comment what it does. It puts symlinks to /mounts from all imported file systems. So any machine which sees an updated database first identifies, am I the receiver, the client, on any exported stuff? If so, I want to know about it, and I'll make sure that my configuration files say that I'm willing to import that. Am I the exporter of anything? If so, my export files have got to say that. And so we used to use auto mount daemon, and we can still build those, but mostly we're using something called the auto file system now. And it builds, for example, this file, autofsmounts.conf. And we can actually glance at that file. Here's what it looks like. These are the ones that I am importing on this machine. It's just a list of imports and where to put them. So this machine imports about 20 different file systems on demand. The auto mount daemon only mounts things when you need them. And after a while that no one's been using it, it unmounts them. It also builds this. And that's the one I just looked at. Hold on.
the one I wanted to look at next. Well, my notes are here. Etc. exports is what I wanted to look at, which is up here. I'm using VI, and if you put the cursor using VI on a file name, then there's a command saying go to that file. It's obviously GF, right? Anyway, here is that file, and it's got some very long lines. So this is on AL. AL is exporting LD3 to what machines? Well, that macro set theoretic expression has been expanded to all of these machines, and each one has got the necessary stuff. And that was built automatically by the reporter the last time the mounts relation was changed. So LD3 is exported. This is only one line long, but it's a very long line. All right, I want to show you another table. We've got a table for mounts, we have a table for hosts. Here is Al's host entry. It says, here's my full name. Here's a short name for you. Give even shorter names sometimes. I'm also known as Finger, I'm also known as DNS, which means people can get to me by talking about dns.cs.eng.uky.edu. Our web server is actually Bud, but it has an alias www. And that's all in this file. In fact, I can find that right here. Here it is. Here's Bud, and it has an alias www, also www3, I don't know why. Here is its IP address, and other information we might want to know about it, such as where it's physically located, who's using it, and very importantly, let's go back to the top of that. And go back to looking at AL. It indicates what is my host class. I am a CS machine. I'm also a stable machine. I'm also a server. I'm also running Intel as opposed to a Mac. I'm running Linux, and I happen to be a DHCP server. These are all used then as macros for other things. So this is where the macro is actually defined, by the fact that this particular element is in the host class. All right, and one of the things that Al builds, being a DNS server, is the DNS tables, the domain name service tables. Let me show you what they look like. This was built recently, automatically, the last time that host relation was changed. And there's a bit of boilerplate at the top, but then for every machine, it tells how to find it. So our machine Apollo, it's got an internet record, an A-type record, saying this is my IP address. I also have an MX record, that is, if you send mail to this machine, where should it actually go? Oh, it should go to Satchmo. I also have a shorter name, APO. I'm also called NPP. So these are the other, this is built automatically. Most of the machines on campus, the DNS stuff is centralized in the IT department. They let us run our own because we don't make mistakes. We never build this file by hand, which would be very error prone. This is always built by our software on whenever the data change. All right, let's move on to something else. Packages, I will show you that. We have switched recently, in the last few years, to using Ubuntu distribution. Ubuntu is nice because if you want to have a particular facility on a particular machine, all you've got to do is use apt-get and install that package. But not all people need the same stuff. And so if you check here for what Gloucester uses, it turns out that I wanted LibreOffice Java Common, and other people might not need that. I also wanted FOP for some stuff I was doing. It's an unusual package. I needed it, others don't. Because of this, anytime we reboot Gloucester and need something, it can always refer to the package list, and it can find things. So this is where we list the unusual packages that people need. So my machine will be a little different from anyone else's because it'll have the FOP. Of course, if we need to install FOP on someone else's machine, we can do it by hand, and we can add it to this list. So in the future, it will always have it. Yeah.
If that's just your personal machine, what cost your personal machine?
Well, it's not my, it's my departmental machine that I have on my desk in my office.
Okay. Why can't you just type apt-get FOP on your own?
Because I might not have permission. I personally do have permissions, but most of our users are not given permission to
Okay.
do apt-get.
Okay.
But if someone else wants FOP, we put it in the list here, and then from that point forward, they will have it, even though they can't themselves run the necessary software. All right, now I want to show you how we monitor potential problems. That's an abbreviation for something that you don't need to know about. Oh, I'll tell you what it is. I now have mounted all of my files from Al, even though I'm on a machine that is not exporting it, not importing it. It's done by some magic I won't go into. And it says that I couldn't find the comment. Why is that? Let's try this one more time. There we are. Now we're in a directory called Pulsar, and what I want to do is I want to show you the current status of all of our machines. It's connecting, and there it is. Okay. So I just built this version of it, Paul, today. Big secondary, which has bigger font, so you can see it better. So every one of our machines, and a few things that aren't machines, have got a button here. And let's look at one that's happy, like Fawn Lily. That's one of the multi-lab machines. And if I look at that, well, it's off the end of the screen. Let me, hold on while I resize the screen again. And I'm just gonna do it this way. Go to Fawn Lily. All right, here are the various things I know about. The CPU, last time it reported was at 5 minutes to the hour, and it says I've got 8 cores, and I've got 98% idle, I'm happy. Green means happy. How about disk slash? It last reported at 10:55 this morning, and it's at 72% of capacity, lots of space left, that's happy. So all the green things say I'm happy, and look at what we look at. We look to see if the Ethernet is happy. We look to see if files are sane. File permissions don't seem to have any errors. How about sensors? Well, the temperature at the moment was 21 degrees centigrade. It would be high if it got to 99. This is a happy machine. How about a machine like Duke, which isn't all that happy? Well, what's unhappy about it? Its disk, D3, is up to 89% of capacity. It's still got plenty of room. This is an enormous disk. I'm going to tolerate that amount of badness. It's now gone from yellow to green there. And here's another disk. Oh, it's got so much room left. I'm going to tolerate that level of badness. And so on. I've now tolerated most things from Duke. The only thing I haven't tolerated yet is, memory. QEMU is using 25% of memory. QEMU does that. I'm going to tolerate that one as well. Duke is now happy. So we can look at this, and actually on Paul's desk, on his machine, he sees this. And he can watch this, and he can tolerate things on a personal basis, or he can ignore things. And so he can see if something new has happened. Some of these things are not machines, but they're more general, like security. And this says that something might have changed on Al. The signature looks wrong on Chrome Sandbox. This is an intrusion detection. Every one of our machines on a schedule runs testers. They're called pulse monitors. I built this a number of years ago. And so one of the pulse monitors looks at the cryptographic digest signature of important programs and compares it against the one on file. If it's different, it sends a warning to Pulsar, which is this tool. And so That apparently happened today at 11:48. The signature looked wrong.
Well, Chrome Sandbox keeps changing every time we upgrade Chrome. So it does keep looking wrong.
Usually we can ignore that one. What's wrong with Amaryllis? It's getting an unusual error on its SSH daemon, a protocol error. Someone is trying to hack it. Well, that leads me to my last subject today. So I'm going to leave this behind now. You can come to my office and I can give you more details on any of this stuff, by the way. Preventing repeated attacks. I'm going to go now to a different machine, Gloucester, and I'm going to do a grep for a particular IP address on an authorization log just to show you that there have been attacks from this particular place. From 153.99, failed password for root. There are a lot of error messages coming into the authentication log saying someone's trying to break in, trying to find the password for root. Well, what can we do about that? Let me show you. We run something called fail to ban, which looks at that log, and if it sees certain patterns, and we can identify whatever patterns we want, it can do whatever action we want. So, the first part of the output is just looking at that authentication log to see how many times someone has tried to break in on various days. And it was only 62 yesterday. Today isn't over yet, 24 so far. That's actually pretty good. Before we installed this, it was in the thousands every day. The next section is the fact that we banned things. How do you ban an IP address? By putting it in your firewall. And so, over time, we have banned various things, and if I try to see that particular fellow, which is this guy here, it looks like January 26th we banned it for the first time. February 15th we banned it a second time. The 21st we banned it 3 times, that's enough. It's time to ban it as a repeater. And so we put a more permanent rule in the firewall at that point. And now it can't get through at all until we change the firewall rules. Now most of our machines use IP tables on their own machine to do the firewalling. However, some of our machines, like the one I'm currently talking to here, use a software-defined network box, which is upstream of a lot of machines. And we put the firewall rule there, dropping all traffic from these offending places. So the first ban, like this guy here, the first time, we just put a 5-minute rule in. But after 3 times, if the 5-minute rule expires, it comes back. If that happens 3 times, on the 3rd time we put in a permanent rule. So that's a permanent rule. And we can see now, for this guy here, the one we've been looking at, in the 3rd section here, that it's blocked forever. This is now sorted by IP address. It's blocked forever, and it's been a permanent block for 18 hours. And since it was blocked, it still tried to send through about 2,000 packets. We have other machines. Now, the whole firewall was reset a day or 2 ago, which is why none of these have been around for more than about a day. But here's one that the rule's been in for almost 2 days, and meanwhile we've gotten 4,300 packets. Here's one that's been around for a day, and it's given us 45,000 packets that we've dropped. Not only at the firewall, but they didn't get to any machines beyond the firewall. All right, some recent news finally. I just have a few more recent things that have happened. For example, new student accounts now can use their Link Blue accounts. In the Laboratory for Advanced Networking, there was a machine that got hacked. I keep records of these things and report them to the necessary parties. We had a problem with AL, which is our DNS server. So we built a secondary DNS server so that if AL is down, people can still find out our machines. And various attempts on Satchmo. These are not so important, it was just in case I had time. So that's a quick overview of how we do system administration when I'm wearing my hat as the person in charge of the computer facility here, which is one of the several hats I wear. Good. Well, we're out of time. I can take 15 seconds of questions. Well, Java use sets up.
Okay, I have a question.
Sure.
Do you roughly monitor how the use of these machines changes? I suspect a lot of students do their research work on their laptops, not on our computers. And there must have been some change between 20 years ago and now.
Yes.
And that may be reflected also in things that you collect.
Yeah, for example, the multi-lab is not used as much now